Space. It's time for Dylan's story. Thanks very much to the Auckland Stardome Observatory. Talking space stuff. G'day there, Dylan.
G'day, Wammo. Nice segue. Did you cue that up especially?
No, I didn't actually, but I think the planets are aligning this morning, shall we say?
Yeah, let's say that.
Yeah, let's just say that. First up, let's talk about, because I think this follows on nicely from our shuttle talk last week, about the space station and the plans that NASA, well, I guess the space community worldwide has for the space station beyond 2020.
Well, they've always known that it's going to be a problem to dispose of putting such a large object up in there. Basically, if you just leave it, its orbit will degrade and it will fall into the Earth, and if that happens, it's going to fall somewhere which could be very bad. There's two options to get rid of it. One is to blast it off out into space, out into never come back sort of thing.
Yeah. And
the other is to give it a controlled descent and break up into Earth. Now, the ISS is too big to launch it out into space. It would take too much energy. It would take so much energy to get all that fuel up there. So the other option is to give it a controlled descent where it partially burns up, partially breaks up and lands in the ocean. So that's what's going to happen. It's going to be its life is going to be it's extended out until 2020. So we've got a few years of it left yet.
Well, I don't understand is that why the need to crash it into Earth? Why not? If its orbit is degrading, help it along and bump it back into an orbit that'll sustain it for even more years. I don't understand why destroy it.
Well, they do anyway because it degrades something like every 10 months or something. They have to boost it. So one of the things the space shuttle carries up is fuel for its engines, because it's high up in space, about between 300 and 400 kilometers up, but still there's a little bit of atmosphere there. So there's still some atmospheric particles which over the course of time create a drag which slow it down, which bring it down lower to Earth.
Yeah.
So it needs to be boosted up regularly anyway, and around 2020 is expected to be the end of its serviceable life. So parts degrade, materials degrade. That's basically the cost of keeping it running beyond that point is predicted to be beyond the not worth it line.
This seems a terrible waste because they are going to want another space station beyond that, aren't they? I mean, because there was the Mir space station from 83 to 98, and that was sunk in a similar way out in the Pacific. Yeah. So they're going to want to build another one, but it just seems like an awful waste of resources.
Yeah, well, it's the same as the shuttle, I guess. I mean, it's a perfectly functioning spacecraft, but just materials don't last that long. Same as on Earth, things don't last forever. And I guess that's the point from an engineering perspective, where it's just not worth it anymore.
Yeah, and I guess no astronauts go down with the ship, though, do they? There's no one up there controlling that descent.
No, I don't think anyone will be volunteering for that one. It'll be
suicide mission.
Purely roboticized. It would be quite a good way to go, though, if you wanted to. I don't know. If you had a terminal disease or something.
Perhaps you stream it on the way down. Let's move on to the big discovery of the week. Well, it has been discovered last year, but it was announced this week. We've got a fast follower, or are we the fast follower? What is this thing that we're in orbit with?
It's a Trojan asteroid.
A Trojan.
A Trojan. Now, Trojans were discovered orbiting around Jupiter as early as 1906. And the first one discovered was named Achilles. So that sort of started a trend of naming things after the Greek war heroes, the Greek and Trojan war heroes.
Yeah.
And so they've become known as the Trojan asteroids. Now, if we think about the ones around Jupiter, if you look at a map of the solar system from above and you map out the asteroids, there's a big group of them following Jupiter around and a big group of them leading Jupiter. Now that's because these are what we call the Lagrangian points. So Jupiter's got gravity, it's orbiting the Sun. The Sun's got gravity. There's a point where the Sun's gravity and Jupiter's gravity effectively cancel out, leaving a sort of neutral area of space.
Okay.
In fact, there's five of those points. They're called the Lagrange points. But the L4 and L5 Lagrange 4 and 5 are fairly stable. So it's been compared to having a flat tabletop with a little bump in it, and you roll the marble round. That's where the marble ends up.
Okay.
So gravitationally, that's where all these asteroids have ended up, in the Lagrange points.
Would it be fair to say? Would it be fair to say that this asteroid missed out on becoming part of Earth back when Earth was created? You know how like all the stuff was out there floating around and all kind of clumped together. Yeah, that's a basic way of probably explaining it. And this bit missed out.
Yeah, I think that's quite plausible actually, because Earth, the sort of mass of Earth would have already been in place. So something that was on a similar orbit, instead of coming and joining Earth, might have fallen into the Lagrange point.
Yeah.
There is another theory that these Trojan asteroids are captured comets. We don't know a lot about the makeup of them, but something about the reflected light says that they might be composed more of dust and ice rather than rock. Therefore, they might be captured comets, but that's to be seen. So anyway, one of these has been discovered around Earth. Now, why has it taken so long to discover them? Well, because they're leading and trailing Earth. They're on the same orbit as Earth, but because Earth's orbit is curved, they're always more towards the sun. So that means that they're only ever going to be visible from the day side of Earth.
Oh, right.
And in the day, it's obviously very hard to look for these things through telescopes.
Yeah.
So astronomers have been searching for them, though, and what they used was the WISE satellite, WISE Sense for Wide Field Infrared Survey Explorer. That's up in space. It's looking at things in infrared, so it's not so distracted by sunlight.
Yeah.
And yeah, in 2010 it found this object, and it's just been confirmed and therefore announced now. These things take a long time to be checked and reviewed by the scientific community. So Earth has a Trojan asteroid confirmed, and the fact that it's got one possibly means that it's got many that we need to look for.
And is it useful for space travel for us?
Well, the thing is that logistically and technically, it's the most likely next target for human space exploration. So we've gotten to the moon, been there, done that. Need to go back, but it's too expensive. But possibly the next step beyond that might be one of these Trojan asteroids. Now, the moon is on average 384,000 kilometers away. The Lagrange asteroids are 80 million kilometers away. So a significant increase in distance. But because it's on the same orbit as Earth, that means that makes the trajectory for a spacecraft very energy efficient.
Right, of course. Okay. But I would imagine it would be a fairly hostile place to try and land.
Oh, completely. Yeah. This one discovered is only 300 meters across. So,
yeah.
Well, actually, I mean that can make it easier to land on, because you don't landing on Mars is one of the biggest barriers to going to Mars. How would you get something that big down there? Because it would crash because of Mars's larger gravity.
Yeah.
We can only land small things on Mars. But this an asteroid of this size, you could basically float right up to it and sort of get captured by its gravity. I guess the actual final landing part would be quite tricky because it's going to be a pretty jagged rock. Or perhaps it's not a rock at all. Perhaps some of these asteroids that are captured comet nucleuses are more sort of, what do they call them? Conglomerations of bits of rock and ice. So they're not actually
solid.
Likely to be a solid thing, but more just sort of a clump of things. So
you could bump into it.
Could be very tricky.
Bump into it. It would just fly apart. Potentially.
Yeah, but potentially though, there's a lot of gravity pulling it together. It would take a pretty big impact to actually push it apart. But
well, it's nice to know we're not alone. We've got a wee Trojan out there. That's lovely news. Bless you.
Possibly many. Yeah.
Yeah. Okay. Well, great. Good-o. You won't be able to see the Trojan from the Auckland Stardom Observatory, but you can see plenty of planets and things and stars and whatnot, and it's all good there
Lots
late
of
night.
Cool stuff.
Yeah.
Yes.
Thanks very much, Dylan.
Yep. Thanks, Wammo.
Dylan Storey there. You can continue the conversation, ask him a question, perhaps on Twitter as well, twitter.com/Dylan Storey.